Hey guys, Miss Gill here. We are moving along to lesson 1.2. We're going to talk about transformations of linear and absolute value functions. So by the end of this lesson, hopefully you can say that you can write functions that represent transformations of linear and absolute value functions, identify transformations of linear and absolute value functions, and explain how translations, reflections, stretches, and shrinks affect graph of functions. Now, this lesson last year was a doozy. So this may be one of those lessons that you really want to work in a small group with me. So take down all the notes, and if you feel good and you want to start the practice and you're like, okay, I got this, then fantastic. But if you come to class and you're like, okay, I thought I felt good, but I don't know what I'm doing, then that's fine. Pause the practice and let's talk about it, because I promise you're not the only one. This was the most small group I did last year in chapter 1. Like it was 1.2 was like the most needed talked about lesson. I don't know how else to put it. Sorry. Hopefully you understand what I'm saying though. Okay? All right, so let's get into it. We're going to write transformations of functions. It is important to know the difference of an input and an output. All right, so for example, an input is the value, the letter x. An output is what f of x is equal to. So you input a number to get out an answer, so to speak. So just an idea to keep in mind when we talk about these different types of transformations and rewriting them. Okay, so we are using this function right here. F of x is equal to 2x plus 1. That color does not show up that great. We are using that to do both a and b. So we're going to write a function g whose graph is a translation 3 units down. So we're translating 3 units down. So if we're moving up and down, we know that that is the y-axis. So that means that it affects the function. So we're going to take our function and we are going to add not 3. We're not adding, lady. Come on. Get your summer brain off and teacher brain on. Okay, so let's let Ms. Gill get her words right this time. So if we are translating down, that means that we are going to subtract from the output because it's down. Now, you should have a key ideas paper that I handed out. You're going to put this in your notebook. It was just too much to put on here. But notice that you can use this for help as well. So we're going down. I know it says plus, but technically you're adding the negative. We're going to just treat it as subtracting. If you go, here's the tricky one though. If you're going to the left, you're going the opposite. So we'll look at this in just a minute, but because there's a negative in the formula, it's kind of the opposite direction. So if something inside parentheses is being added, you're technically going to the left. If something being subtracted, you're technically going to the right. So we will talk about this, but just so you know, anything that we have here, this has lots of good stuff on it. It was just too much to stick right above these and have the paper not be too much. All right, so right back down to it. So we are subtracting to our function. So that's all that means. We're going to translate 3 units down. We're going to subtract from our function. Well, what was our function? 2x plus 1. So we're just going to rewrite 2x plus 1, and now we bring down our minus 3. And we can combine our like terms. We have 1 minus 3 is negative 2, so we end up with 2x minus 2. So it did say write a function g, so to be professional, we're going to say g of x is equal to 2x minus 2. So that is how the function changes based on it translating down 3 units. All right, if it translated up, you would have added. Okay, if it goes to the left or right, we're going to look at that now. All right, so remember, because this was going down, this dealt with the output. All right, so the whole function. All right, so now we're going to look at, this one says, write a function h whose graph is a translations 2 units to the left. So 2 units to the left. So that doesn't affect the function, it affects the x, right? Because now we're going this way across the x-axis, so it affects our x. So this one affects the input. So basically what we're going to do is replace x. All right, so Ms. Gill, what do you mean by that? Well, let's write it down. We're going to write down our function, 2x plus 1. All right, but we are going to replace x. In this case, we want 2 units to the left. So now keep in mind that the formula is x minus h. Okay, so keep that in mind, x minus h. So we are going to replace x with x minus, now because we're going to the left, it's -2. This part sounds tricky, but just bear with me. Just bear with me. Okay, so all we did was we took x and we replaced x with x minus -2. Why -2? Because we're going to the left 2. So we're going on in the negative direction 2 units. Why the minus sign? Because I showed you the formula. All right, the rest we're just bringing down. So we're going to bring down the 2 and we are going to bring down, need to put a plus sign there, lady. Sorry guys, I'll eventually get my life together. I enjoyed summer vacation way too much. Hopefully y'all did too. All right, so let's simplify. We know x minus a negative number becomes x plus 2. We still have plus 1. Can we leave it like this? We don't want to. We want to do distributive properties, so let's take that 2 and let's multiply it to both of those. So we would have 2 times x gives us 2x. 2 times 2 gives us 4. We got that plus 1. Oh, look. Now we can combine our 4 and our 1. So if we do that, I like writing underneath, so I'm just going to keep going. If you want to move to the right, you can. So we have 2x plus 5. All right, so we can write it professionally. We're using h, so we would say h of x is equal to 2x plus 5. Now, we're going to work on how inside the parentheses it means the opposite direction. You will become a pro at determining that by the end of Algebra 2, so no worries there. Again, this lesson can be tricky to some, so if you get stuck, if there's a question you want to talk about a similar one, star it and ask in class, please. That's why I teach this way, so I can help you as much as possible during class time. All right, moving on. We have a new function, the absolute value of x plus 3 plus 1. So we're going to write a function, g, whose graph is a reflection over the x-axis. So we're reflecting over the x. So the x-axis would be a vertical movement, right? So we're flipping vertically, so that affects our function. So we have the reflection. I don't like reflections of linears. They're a little harder to see, but just know if you are reflecting vertically, you multiply your output by -1. If you reflect horizontally, so over the y, then you're multiplying your input by -1. All right, so since we're reflecting over the x, it affects our output. Out what? Miss Gill, you're killing me. Like, lady, get with the program. Learn. Like, school is in session, man. All right, so output. All right, so that means that we're going to take the entire function. So the entire function, and we are going to multiply that by, you got it, -1. All right, so we're going to take -1. We're going to multiply it to the absolute value of x plus 3 plus 1. All right, so again, I like to do questions that are a little challenging with you guys, so that way when you see one, you're not like, Miss Gill, what the heck are you doing, lady? You confused me. All right, so We're multiplying this -1 to this whole function. We cannot go inside the absolute value bars. I'm going to say that again. We cannot multiply inside the absolute value bars. It is not parentheses. It is not distributive property. We can multiply to the absolute value, cannot multiply in it. So I'm going to show you what that means. So we're going to multiply. So this is going to become a -1 absolute value of x plus 3. -1 times +1 gives me -1. However, and you don't even have to put the -1 there. If you have just the negative, that is technically the professional way to write it, but I know it bothers some of you if I start dropping ones. All right, so technically that's how it looks, the negative absolute value of x plus 3 minus 1. However, there's a catch, because in math, you know, some of those mathematicians, I'm kidding, wrong question. Oh, dear Jesus. Okay, sorry guys. It's the next one that's a doozy. Is it? Yes, it's the next one. Sorry, I was thinking it was this one. I mean, it's only like the 4th time I've taught this lesson. You'd think I would be a professional by now. All right, goes to show you we make mistakes too. So anyways, this one isn't that bad. We're just going to say g of x, gosh lady, is negative absolute value of x plus 3 minus 1. And voila, that is your answer. Ignore all that rambling I was doing because that was for this one. Because the horizontal ones are extra. All right, so vertical movements are easy. Horizontal ones, you have to think a little extra about it. All right, so this one, it says, write a function of h whose graph is a reflection on the y-axis. So this affects your input. So what does that mean? We're basically going to take x and we're going to replace it with -x. Okay, because if you want to look back at your key ideas, that was what we just looked at earlier. So we're going to take our function, absolute value of x plus 3 plus 1, but now instead of x, I'm going to replace it with a -x, and then just write the rest of this stuff down. Here's the doozy. In math, they make rules. This can't be negative inside the absolute value bar. So I could go on this long, confusing rampage on how you have to multiply this by a -1 to get it to change and blah, 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 blah. I'm just going to keep it short and sweet and to the point, and I'm going to say that it can't be negative, so we're going to switch the signs. There is a mathematical reason to that. If you would like to see it, I would be happy to show it to you, but I know if I do the 3 steps that it takes to show that, I'm going to lose some of you. So some of you are easier, you like tricks and tips, so this is a trick or tip. So it can't be negative, so we're going to switch the signs. All right. So what does that mean, Miss Gill? That means we're going to have the same thing, but instead of -x plus 3, we're going to have x minus 3. And then we're done. All right, so it can't have a negative inside. There is a whole long, drawn-out thing about multiplying by -1. It's ugly, but I will show it to you if you want to know. So our final is h of x is equal to x minus 3 plus 1. So we reflected, this also has to do with, it was positive, so that means it was on this side of the graph originally, right? So it was positive, so it was on this side of the graph. We flipped it over this way, so now it's on this side. So it does change just that inside. So just like how these moved left and right, it does change just that inside portion. And like I said, we're going to be dealing with this the entire Algebra 2 class, so you will get to where you're understanding that a little better. Okay, moving on. Next kind. So now we have let f of x equal the absolute value of x minus 3 minus 5. A function g whose graph is a horizontal shrink of the graph of f by a factor of 1/3. So here's the thing. Again, the horizontal movements are horrible. All right, the horizontal movements are horrible. You will learn that. But one of the great thing is that since it's a horizontal shrink and our factor is 1/3, that means I am going to replace x with the reciprocal of 1/3. Yes, I said reciprocal. All right, so let's have a quick rundown on reciprocals. So the reciprocal of 1/3 becomes 3/1, or simply 3. All right, reciprocal. So remember when you learned how to divide fractions, you can't divide fractions, so you multiply them, keep, change, flip. Well, the reciprocal is your flip. So only when you're dealing with horizontal, you must use the reciprocal. Horizontal only. All right, so let's make a note over here. Horizontal must use reciprocal. All right, horizontal must use reciprocal. So what does this mean now? Horizontal, I know that affects my input. So that means that I am going to basically take x and I'm going to replace it, the reciprocal is 3, with 3x. All right, so I'm going to rewrite my function. So my function is x minus 3 minus 5, but instead of x, I am replacing x with 3x. Can I simplify anything? No. So even though this was annoying, actually working it out wasn't too bad. So we are doing a graph of g, so just for professional purposes, our final answer looks like this. Okay, so that part wasn't too bad. It's just the hardest part of this is remembering you have to use the reciprocal. All right, so looking at part B, a function h whose graph is a vertical stretch by a factor of 2. So that means it is affecting the output. So that means we have to multiply the entire function by 2. So we're doing 2 times f of x. So let's do our 2. We're going to bring down our f of x. What was that? It was the absolute value of x minus 3 minus 5. Now, keep in mind, these are not parentheses. These are absolute value bars. You cannot multiply inside the absolute value bars. So we're literally going to take this 2 and multiply it here, and then we're going to multiply it to the negative 5. No, you do not multiply the 2 to the negative 3. All right, because it looks like this. 2 on the outside of the absolute value bars. 2 times negative 5 is negative 10. We are not replacing anything inside. That's horizontal movement. Vertical movement is outside. We cannot multiply inside the absolute value bars. We can only multiply inside parentheses. All right, so to make this look a little more professional, I'm just going to write h of x right here instead of rewriting it because it's the same. Some of y'all hate it when us teachers put things on the other side, but we don't really care. It don't bother us. So if you want to rewrite it and have the h of x on the left side, that's perfectly okay. Hopefully I haven't lost you yet. Again, I'm going to remind you that this one is a doozy. If you come to class and you're like, yeah, I don't think I'm ready for this practice, let's sit together in a small group with other people who feel the same way as you, and let's work through a couple together because I do have some extra practice problems that we could do together. Okay, so let's go here. We're going to describe the transformation of f of x is equal to the absolute value of x plus 2 represented by negative f of x minus 1, and then we're going to graph each function. Fun, fun, fun. All right, so let's start off with our parent function. We know that our parent function, this is a, why did I skip this one? Oh, lady. Well, let's go for it. We'll go back to that one. Okay, starting off with the parent function. This crazy lady skipping questions. We'll come back to it, I promise, because that one is one that I want to make sure you understand. So this is our parent function. We're going to call it PF for parent function. Okay? So we are describing this transformation. So let's graph this one first. Because it's plus 2 inside, that tells me that it translated to the left 2 units. So I'm going to graph that now. So I'll go 1, 2. And so it looks exactly the same. It's just moved 2 units to the left. Why to the left, Miss Gill? It's being added because I told you the horizontal one is extra. And as you learned in Algebra 1, it goes the opposite directions. Okay, so we have our first two. So this was f of x. So let's name him f of x. All right, we got those two. Now we're going to describe this. So what is happening here? Well, I have this negative in the front. So we have learned that if it's being multiplied by a negative, it is a reflection. Since the f is being multiplied, we're going to say that it's over the x-axis. And then if we have a minus 1 inside, that means we are moving it to the right one time. So if we describe that, we would say that the graph of g of x is a reflection over the x-axis followed by a translation 1 unit to the right. And I will get you a little reference with these to help you easily go back and look at which direction, what does each thing mean, all that in one spot. So I will eventually, hopefully soon, get that together for you. Okay, moving on. So now we want to move the graph to the right one, and then we need to reflect it. So we're going to take this, we're going to move it to the right one. That's all we're doing. And then we're reflecting it. So now it's going to face down. I'm trying to get it to go through all the corner of the boxes, but this color pencil is not pretty. And this is g of x. So we have now graphed them all. All right, hopefully that one wasn't too bad. Again, this kind of stuff right here, we're going to be doing every chapter with different types of functions. So you will get better at it the further we go through. All right, we got what? 1, 2, 3 questions left. Describing transformations on a table. Okay, I'm going to point this out because this is something that people get confused easily. Every year I see it. Every year I try to make it as simple as possible. Notice that our x is not changing. What's changing is we're going from f of x to g of x. So our function, our output, is changing. So an output is only a vertical movement. So we only have a few options. It's either going up or down, it's reflecting over the x, or it's stretching or shrinking vertically. Those are our only 4 options. So we need to look at from 10 to 5, 6 to 3, 2 to 1, 6 to 3. What is happening with those numbers? So think for a moment, what is happening? What is the pattern? If you said divided by 2, you are correct. However, we haven't really talked about any transformation being divided. So we're going to rewrite dividing by 2 as being multiplied by 1/2. Okay, same thing. Dividing by 2, multiplying by 1/2, literally the same thing. So now we need to know, well, what type of function multiplies by 1/2? So if we go back to our key ideas, we got our horizontal stretches, our vertical stretches. Well, we know it's vertical. We are multiplying, right? So our value multiplies to the function. So what is multiplying to the function? 1/2. 1/2 is between 0 and 1. So remember we said that in the last lesson, in lesson 1.1, between 0 and 1, it would be a vertical shrink. To 5, followed by a translation 3 units up of the graph of f of x, write a rule. All right, so we got a couple of things going on here. So a vertical shrink, remember that is going to affect the output. So we're going to multiply our x, our function, by 0.25. All right, so let's start with that part. They gave us x, so let's vertically shrink by a factor of 0.25. So that means we're going to multiply f of x. Well, in this case, our f of x is just x. So we're just going to take our x and we're going to multiply 0.25. Don't know why it's so squished. All right, so then followed by a translation 3 units up. So that also affects my output. And I'm going to add 3 because I'm going up. So now I'm going to take my whole entire function, which is the 0.25x, and I'm going to add 3. So to write it professionally, g of x is equal to 0.25x plus 3. I know you guys hate fractions, but for some reason, when you see a decimal, you want to turn it into a fraction. Do not turn that into a fraction. If your question has a decimal, your answer has a decimal. Question has a fraction, your answer has a fraction. Y'all be doing some crazy stuff sometimes. So yes, that is it. Sorry, that's all we had to do to that. So take it one step at a time. What? Yeah, lady. Just to let you know, if you ever see this, it just means, well, can't spell. It just means write an equation. So whenever you see rule, you're just writing an equation. Okay. All right, last one. Some of you can do this in your head, which is perfectly fine for me unless I ask you to explain. All right, so we're going to do this real quick. You design a computer game. Your revenue in dollars for X downloads is given by this function, f of x equals 2x. And your profit is $50 less than 90% of the revenue. Well, what is the revenue? 2x. So we have $50 less than 90% of this. So like I said, some of you guys will do this in your head. I'm going to write an equation. All right, so then we have to find out what is the profit for 100 downloads. All right, so if I have $50 less than, I know I'm going to take my 2x and I'm subtracting 50. Then it's less than 90% of the revenue. I should have highlighted that part too. Well, what is the revenue? 2x. So we're just going to multiply the 2x by 90%. All right, another way to write 90% is 0.9. No reason to put the 0 behind it. So then we're going to multiply that to 2x, and then we would say minus 50. So if I multiply 0.9 times 2, I would get 1.8x minus 50. So now I've rewritten an equation. So let's just call this P of x for the profit. So now, no matter how many downloads, I can use this equation to figure out what the profit would be. But they want me specifically to say 100. So let's plug in P of 100. And then we're just solving. So if I got 1.8 and I'm going to multiply it to 100, that is going to give me 180, right? 1, 2, yes. Minus 50, which would give me 130. So my profit would be $130 for 100 downloads. Again, I know some of you could have did the, Miss Gill, I did this in my head. That's fine. But this is what you did in your head, logically written out. All right, guys, so that finishes 1.2. Sorry, this one is longer. Like I said, please, please, please come to class ready to ask questions. If you get stuck, please ask questions, okay? All right, I will see you in class.